Cool. Yeah. Thank you, everyone, so much for your time, and thank you, Katie, for having me. I'm excited to be here. I wish it was in person, but hopefully, in a couple of quarters, maybe. And yeah, similar or very much in line with OWASP. We're also huge fans of open source. So yeah, today I want to talk about an open source static analysis tool we've been building, and I have some content prepared and some some ideas, some live sort of hands-on demos where we can like write some sort of custom rules together. But really, if there's something in particular you want to talk about, or if you're like, oh, I am already familiar with this part of it and I'm bored, just like let me know. We can talk about a lot of things. Like topics that I'm going to touch on a little bit, but not in detail. So just like let me know if you want to get into more detail are, tackling entire vulnerability classes, or sort of like more intricacies about static analysis and sort of fundamental trade-offs there, because both are topics I'm very interested in. So I'm going to touch on those today, but it's sort of because we're going to talk about a lot, I'm sort of going to do just sort of like an intro about a lot of things. But yeah, let me know what's interesting to you. So cool. Yeah, without further ado, let's get into it. So as I'm sure all of you are aware, there's always a lot of stuff for us to do, right? So depending on your company, you're probably doing some threat modeling, code reviews, pen testing, advising different development teams, training, bug bounty, and so forth. But at the same time, there's even more and more for us to do with new code being written and deployed to production faster than ever with the adoption of Agile and DevOps. And one thing I see across a lot of companies is this sort of shift from security teams being sort of this final gate that development needs to pass through, and rather being like, okay, how do we, allow engineering teams to move quickly, but at a acceptable level of risk? And fundamentally, I think what we need to do with sort of small security teams supporting large engineering teams is like scale security. And how do we do that? And I think the answer is there's many ways. Depending on if you're talking about corporate security or infrastructure security or like cloud security or container security. In this talk, I'm going to focus more on like application and like software security, because that's more sort of in line with OWASP's bread and butter. And in that space, in application security, one thing I've seen across many companies, and I can give a bunch of examples if you'd like, is that the answer is sort of like building secure defaults. So ways that solve bug classes by construction, such as, how do we always output in code by default? How do we parse XML in a way that prevents XXE and things like that? Just define, Netflix calls it like a paved road, like how to do things the right way. And then basically use sort of lightweight customizable tools to enforce that these secure defaults are used. So this is, I think there's a lot of interesting nuance there. And actually just this topic alone could be a whole talk. And in fact, it was. So my colleague and I spoke at Global AppSec SF in 2020 about just this topic. So if you want to see more about that, or just ask me now, like happy to chat more. But yeah, again, there's a lot to cover, so I'm not going to focus on that in detail in this talk. But so before we get into it, just a very tiny bit about me. So I'm the head of security research at R2C. We're a Bay Area security startup. This is our obligatory Zoom company headshot. We've added some people since then, but yeah, so we're building Semgrep as well as some other tools. So we're very much open source forward as a company. Before this, I was at NCC Group, a global security consulting firm, as a technical director and research director. And before that, I was a indentured servant, grad student at UC Davis. So feel free to say hi on Twitter. I also have a security newsletter that's free weekly, where I try to take the best tools and resources and combine it down into sort of one place that's easy to sort of keep up with things without sort of constantly having to follow everything. So feel free to check it out if that's your style. Okay, so today, first we're going to talk a little bit about static analysis in general and the specific trade-offs that Semgrep makes and sort of how it works. Then we're going to do some live demos of rule writing, like how to say like, oh, there's some code in my organization that I want to flag easily and quickly. We'll show you how to do that. We'll talk a little bit about integrating into CI environments, and then we'll talk about some advanced features. But yeah, so this is the current agenda. But if there's something else you'd like to talk about, or if there's something you want to go into more detail, yeah, just let me know. I'd be more than happy to do that, either by just unmuting and saying something, or writing in the comments, and then hopefully Katie can share with me. Oh, cool. Yeah. So let's get into it, unless someone finds this egregiously offensive and demands that we stop now. So okay. So as a security consultant, I spend a lot of time using grep to search source code. And the reason is, like, it's great, super fast. RIP grep is like a better, faster version. But the thing is, there's a number of cases that are a bit noisy or imprecise about grep. And so here are some examples. These first two are pretty easy to find. But this exec here is like, well, there's some white space. It could be across multiple lines. This is actually, so we're looking for exec, which if user input gets there, could be sort of arbitrary code execution, perhaps. This function isn't actually exec, it just has a similar name, but grep would flag things in comments or in strings. So creating a regular expression or something like that to find some interesting code pattern, it quickly becomes very hard, right? Because fundamentally, regexes don't understand source code, right? And as someone who's written some gnarly regexes, the obligatory XKCD, I had 99 problems, so I used regexes. Now I have 100 problems. So oftentimes they work at the moment, but you look at them later and you're like, ooh, what was I intending here? And so sort of the fundamental challenge is, when you're trying to intelligently search source code, you can't really do that well as a string, right? Because source code isn't just a string in a file. The way interpreters or compilers see it is they tend to build a structured tree out of it, like an abstract syntax tree, or build like a graph where you can sort of reason about the control of data through it. But yeah, so fundamentally, just trying to search source code without being aware of the semantics, just it's going to be really hard, and I think painfully so. So there's a lot of tools that are open source and great that do this already. So for example, Bandit, DLint, ESLint, Flake, GoLint, and all these others. So there's a lot of open source tools that do parse source code into some intermediate representation, then allow you to write patterns on it. But the problem is, a lot of these tools they only support one language, and each one of them represents source code in a different way internally. And often there's different ways to express the same thing, and it's kind of annoying to write checks for all of them. And they tend to not be sort of easy to customize. For example, in ESLint, there's a rule to look for calls to eval, the function. And there's a lot of comments, but it takes 307 lines, which I think for me, if I'm oh, let me grep for this dangerous thing in a source code that I'm looking at, I kind of don't want to write 300 lines of code to do that. There are, of course, commercial SaaS tools that are very powerful, but they can be a bit complex and a little bit slow in CI, and tend to be very expensive. So because of these limitations, we ended up building Semgrep, which is an open source, lightweight static analysis tool that supports many languages. So rather than having to learn, say, 10 different tools for 10 languages, because many companies are very polyglot these days, you can just use sort of one tool and then use it everywhere. So I'll talk about a couple of different use cases based on sort of what might be interesting to you. So for security consultants or researchers, things that are nice are it's open source. So it's on GitHub. I'll show you in a moment. It's LGPL licensed, so fairly permissive. It supports many languages. Here's just a few. I think it's over 9 or 10 languages now. There's over 1,000, I think closer to 1,200 or 1,300 security checks that come for free out of the box that are also open source. It does not require buildable source code. So if you're given partial source code, or you don't have access to some internal dependencies, you can still scan it. And I think the key differentiating feature is there's not this painful domain-specific language to learn. If you're going to try to search for some Java code or some Python code, the pattern you use to do that looks basically the same as what you're targeting, which we'll look at in a second, and I think really makes it easier for both security professionals and developers to use. So why is it nice for internal AppSec engineers as well as developers? I think in every software repo, you have like coding standards. You have like whether that's documented in wikis or in the code itself or just in someone's brain. Like you have these ideas of how code should look and how it shouldn't look. And it would be nice to be able to enforce that continuously everywhere in CI, whether that's GitHub, GitLab, Travis, and so forth. And I think what we're really trying to do with Semgrep is like, how do you take an idea in your head and express it in code as quickly as possible? So that's sort of the meta goal. So I think there's a number of use cases that are not just security related, right? So you can help new developers get up to speed faster. Like if there are, say, some coding standards in your company where it's like, oh, we don't use this standard library function, we use this internal one instead. You could write a quick check so that whenever someone writes the non-approved way of doing things, you're just like write a PR comment that says, hey, by the way, you should do this instead. If you have sort of correctness or reliability expectations of how certain APIs internal to your company are called, you can write checks for that as well. So you're making higher quality code be developed more quickly. And so forth. And of course, there's security applications. So one thing that I think is a useful principle to think about, not just in this space, but in general, is like, how can the security team provide valuable capabilities to our developer customers? So in this case, we're sort of talking about being able to intelligently and quickly search code, but I think this applies to many domains. So for example, let's say asset inventory or visibility, right? This is very useful for security teams because you need to know, like, what do we control and thus what do we need to secure? But like visibility is also useful for engineering teams or like SRE or DevOps teams. So I think the more that we can understand sort of what capabilities and properties engineering teams want, and then get those with security tools or just leverage sort of their infrastructure to do that, I think that partnership can be very valuable. Okay, so if you're thinking about like, okay, where does Semgrep fit in? If you're familiar with static analysis, you know that it's not just like a binary yes or no. There's actually a spectrum of complexity of static analysis. So there's like very easy, dumb things like grep and regex based. There's also like whole program analysis where you're doing inter-file data flow analysis and things like that. Semgrep fits in the middle with something that's like easy to use and fast and powerful, but not quite doing sort of full program analysis. So at a high level, how Semgrep works and how pretty much every static analysis tool works is you take some source code, you parse it into an abstract syntax tree or some like intermediate representation. You combine that with security checks, you do some pattern matching, and then out comes security bugs at the end. Okay, so yeah, any questions so far? So we'll get into some live demos. Cool. Well, yeah, just stop me. And yeah, also, Katie, so is this new and interesting? I don't want to cover exactly the same thing. You're like, oh yeah, I know everything about this.
It is for me. I don't know for the others.
Okay, cool. Yeah, I'll keep going. Just let me know if you're like, oh, okay, this is easy. Let's do something more. Okay, so let's just like quickly, we've been talking a lot about it and its slides, and I don't know, sometimes I'm like, slides, like, is it actually real? So yeah, if you want to give it a spin, it's on GitHub, again, LGPL. If you want to install it with a Homebrew or Docker or like, I think apt or pip, things like that, that's an easy way to do it. If you want to look at the out-of-the-box security checks that are provided, you can go to the Semgrep rules repo. If you want to see just some sort of like high-level description of it and links to relevant things, you can go to semgrep.dev. So one thing that's pretty cool that I just wanted to highlight is we built this like Semgrep widget. So there's basically like an iframe. You can't include this yet on on arbitrary domains, but we're going to fix this soon. But you can actually basically say like, so Semgrep rules are actually YAML under the hood. So this is an example rule where the name of the rule, like its identifier, is Python no prints in production. It applies to Python code. This is the message we would show the user. This is the pattern we're looking for. So notice that it basically looks like the Python code we're targeting, which is we'll talk about the syntax more in a second, but basically we're looking for a function call where the function name is oldPrint, and it has one argument, and we don't care what it is. But if you actually click this little play button here, we're actually basically like running Semgrep. It spins up like a Docker image in the back end, but we're actually like running Semgrep right here as like a widget on a web page, which is pretty cool. I think there's not many static analysis tools that you can just sort of like embed in web pages like that. And soon we hope to make it so that anybody who's like writing a blog post about, say, doing a code audit or code review, or if you're writing some internal coding guidelines for developers, you can ideally say, hey, you should code like this. Also, here's a check that you can view right in Confluence or whatever that shows you how it should be done. Okay, so if you are curious about like, hey, what rules can I get out of the box? So we have if you go to this rules link, we have a bunch of getting starting packs. So this collects a bunch of rules for many languages that are for OWASP Type 10 type issues. We have collected some security checks for, they're like higher signal and fast for CI. Security audits, like a little broader security checks. One thing we're really trying to lean into as a company is secure guardrails. So basically, how can we flag any code that could be potentially vulnerable? So for example, rather than trying to find every SQL injection where you need to ensure that tainted user input goes to an unparameterized SQL query, we would rather say, like, what are all the unparameterized SQL queries? And then if we fix all of those, then user input can go wherever it wants, because it cannot be used in a SQL query in a way that's dangerous. So basically, rather than finding every bug, how can we remove the conditions that would allow a vulnerability to happen in the first place? So we have a number of packs for this already. So this XSS pack is pretty interesting. We went through a bunch of common web frameworks and libraries, and we're like, okay, what are all the ways to disable output encoding? Like, what are all the ways to make something potentially dangerous? And we wrote checks for it. So what we're hoping over time is that if you run this pack and it doesn't flag anything, then it's very difficult for cross-site scripting to ever possibly happen, because just the preconditions that enable it to happen are not met. And we've done that with like insecure transport, like things communicating over HTTP or not verifying certs and stuff like that as well. So we also have some packs for like specific, say, Django or Flask or JavaScript languages and frameworks, or like Docker Compose, Docker, Kubernetes, Terraform, Nginx, like stuff like that. One thing, we were trying to test the sort of expressivity of Semgrep. And so we actually tried porting security checks from other tools into our language just to like see how effective it would be. And we were able to port a number of different security tools, like all of their checks, into equivalent Semgrep rules in just like a few days or a week or two each. So eventually we hope so that rather than running 10 different tools, you can get the same coverage just from running one tool that's also open source and free. If you're curious, you can also go to search and filter by, I don't know, say like Python, security, I don't know, type in like XSS or something. And you can like see various rules or rule packs that map to that. And if you click on them, you can see like what is the actual implementation, like what are we actually checking for, and like here's some unit test code for what it'll match against. Yeah, but so that's basically this. We have pretty extensive docs. So if you have any questions or like, oh, how do I do this? I feel like 80 to 90% of the time, the answer is probably there. And if it's not, like, let us know and we will add it right away. Cool, so that's basically the last sort of big picture overview thing I wanted to say. And now we can get to the exciting parts, which is actually using the tool, because who doesn't like demos? That's always my favorite part. So this is the Semgrep playground. So if you go to semgrep.dev and click playground, it takes you here. So this is going to allow us to write Semgrep patterns in our browser without installing anything. And how it works is you can select any language that you want. And then up here, we're going to write a pattern. And that Semgrep pattern will then be applied to the code here. And anything that's matched will sort of show up here on the right-hand side. So that's basically how it works. So let's say that we wanted to audit our code for the exec example we showed earlier. We're like, exec is kind of dangerous. I want to find whenever that function is called in Python. So if we just copy this line of code up here and click run, what this is going to do is find exactly calls to exec where ls is the argument. But we probably want to find any call to exec. So Semgrep provides basically two helpful abstractions. Mostly you're writing patterns that are exactly source code with like two helpful abstractions. So one of them is the ellipsis operator, or ... And basically what this does is, this is a, if you think of like regular expressions where you have like dot star, where it's like match 0 or more things, that's basically what this does. So here we're saying find calls to exec with 0 or more arguments. So if we do this, we can see that we matched this exec here, or so with like a string literal or a variable. Notice that we did not match this because this function name is not exec, it's some exec. And then this white space and multiple lines, Semgrep understands source code, so it's not tricked by things like these. It did not flag this because it's in a comment, and it also did not flag this because this is in a string and is not actually a function call. And one thing that's especially cool is this top example. So notice how we've imported exec as safe function. We've locally aliased it to a different name. And here we're calling that name on, for example, some user input. So the person writing the pattern didn't need to be aware that functions could be locally called a different name. We just, Semgrep just sort of transparently handled that for us, and we didn't need to care about it. So again, the ellipsis operator matches 0 or more things, so or 0 or more arguments or statements. So if we were to say add something like this, or add something like this, we would this ellipsis operator would match those as well. Okay, so that's like one abstraction. I'm going to teach you about the other one. So after these two, you understand like 70% of Semgrep, and you can start being dangerous immediately. The other is called meta variables, which is $sign and then some identifier. And this basically matches just one thing. And the point here is like, you can think of it kind of like capture groups in regular expressions, where it's like you don't know necessarily what it is, but you want to match a reference to it. So if we use this, and actually, so if we go to advanced mode, we can see the YAML we are building. We can update this message to use the meta variable that we're using in the pattern, and it's actually going to pass that through to the message. So if we do this, we can see we matched user input, $X also matched ls, and so it didn't match these two because by using $X, that means we expect there to be only one argument. So here we're calling exec with no arguments, so it doesn't match. Here it has 3 arguments, so that's not one argument, so it doesn't match. But then we also match some var and foo and bar. So we can actually combine these two operators. So let's say we wanted to match exec being called with at least one argument. So we could do $x and then ... So $x will match the first argument, but the rest of the arguments, like if there can be 2 or 3 or 5, like that's fine. So we're still not matching exec here because we're saying there's at least one argument, but we are matching this now because the ellipsis operator is matching the B and C. Okay, so basically when there's something you want to abstract and you don't care about, you can use the ellipsis operator. If there's something you want to like match a reference to, you can use a meta variable. Yeah, any questions so far?
Certainly, and I have one question here. Clint, we are seeing most of them are like a code-based check. So when we know this particular statement is going to be a problematic one, so we will be able to come up with a rule. And what about the context? Say, for example, when the AAS tree or a systematic tree is built and the data flow is constructed, and only then we will come to know, yes, this particular data flow is going to result in an SQL injection or some particular issue. The statements may be right, but I can clearly say here, yes, this is a call, say get operation or post operation coming from the client, and there is no sanitizing is happening over here. And then this is prone for a particular attack. If the call data flow is not properly constructed, even there is no sanitizing is not there, it will just result in the false positive, am I right? So how that is handled in the Semgrep?
Yeah, that's a very good question. Yeah, so one design trade-off Semgrep has made is in order to be able to scan like just source code without necessarily requiring a buildable environment and to try to be as fast as possible. Semgrep currently focuses on analyzing just within one file. So at this time, it's not trying to do interprocedural data flow analysis.
Yep.
So I, as a security consultant, I spent a lot of time helping other companies with checkmarks, Fortify, and other tools like that, which do. And I actually, when I was a grad student, I did intern at Fortify, and I helped build like some of their stuff. So I'm quite familiar with these tools, and they are certainly like that cross-file analysis can be very useful. In my experience, the longer the call chain, the more likely it is to be a false positive. Like once it gets to like 5 or 10, at least in my personal code review, it's like oftentimes a false positive. But there are some cases with Semgrep where something in another file or like a config setting somewhere is going to set a property which is impactful somewhere else. And currently, Semgrep cannot very effectively reason about that. But the way that we see many companies doing things and sort of the worldview that we believe in and we're trying to support is that ideally your frameworks and the libraries you're using are safe by default. And really what you're looking for is when people are opting out of these protections. So ideally, so I'm familiar with a number of web frameworks, not as much ASP, to be honest. But ideally, it would be like, okay, this framework and this templating library does output in code by default. However, there is a way, so for example, in React, like dangerously set enter HTML, or in Jinja, if you pass something to like bar/safe, or basically like, can we in a localized way reason about people opting out of protections or not using the protections we've given them? So this doesn't work in every case, as you pointed out very correctly. Like yeah, there are some cases where you're like, oh, does user input come from this to this to this to this, and then eventually somewhere bad. But what we would like to do is instead say like, okay, well, we see the place that we are sending data back to the user, and are we encoding things properly there? And if we are, then it kind of doesn't matter if user controls that data or not. Just when it gets sent, like we know it's safe, regardless of whether it's tainted or not. So I don't know. Yeah, what do you think about that? Feel free to strongly disagree.
No. Yes, there are trade-offs, and especially now for the speed is concerned. When I'm waiting for the scan for several hours for me to data flow need to be clearly constructed and need to do the for parsing and back parsing and analyze all those things. And then I throw a result. It takes around some, say, if 1 million lines of code project takes several hours. So this way it is pretty quick. And if it is much closer to the IDE or development environment, this will be much faster shift left. So yes, there is additional benefit and some trade-offs also there. So I agree and a little bit disagree as well.
Yeah. I mean, as with anything, right? There's like a static analysis or any specific tool is not magic, right? There's always trade-offs, and the ones we've explicitly decided to make is like, if you can think of like a dial between like extremely powerful program analysis and very complex language, so like powerful but hard to use and slow, we've opted the other direction, which is as easy to use as possible, as fast as possible, so that ideally it's not like only security researchers can use it, but rather like any competent developer can use it in like an hour, is sort of the goal. So again, it's not perfect for every use case, but at least for this niche, that's sort of what we're aiming at. And if you think about it, like most times you're doing code review, if you're like a developer looking at a new pull request or merge request, you're probably looking at what's changed. You're probably not reasoning about like 10 different files. So if there's something in another file that's causing the 5-line change you're looking at to be dangerous, like probably that's not going to be caught very well in code review. And we would rather develop software in a way such that you can reason locally about the security properties of code, because that's less error prone in our opinion. But again, it doesn't work for every like language or framework or system, because maybe in your environment you need that. But yeah, it could be complementary in that case. But yeah, thanks for your question.
Perfect, sir. Thank you.
So if I am to kind of come to a conclusion from what you said. So we have the large complex tools, which may take like few hours for the entire application to do the entire data flow analysis and etc. And how the data flows between the components of the application and various files. And that's a use case. But Semgrep is great for example, for pre-commit hooks or commit hooks, that part of the code where you actually have a small set of files changed. What about these ones? Let's have a quick check, quick and fast check. And that would be a good point to actually use the Semgrep. Am I correct?
Yes. Yeah. So if you want to use it in pre-commit, we also have a VS Code extension. If you want to scan every pull request or merge request, we aim like PR scanning to take like a few minutes, like at most, like ideally under like 5 minutes. So you're getting like quick feedback. We also make it easy to write PR comments based on findings. But yeah, if you're like, oh, we want like really deep analysis and it's okay if it takes several days, that's not really what we're aiming to do. So I guess one sort of philosophical thing is we aim to be like, if you're a company where security team and engineering can work together to sort of guide how software is written, rather than being like a totally separate external party trying to enforce security on the team. If you're totally external, like that's going to be hard to like shape development practices. But if you can work with engineering as sort of partners and sort of guide, like this is a paved road we want to agree on together, then I think this approach can be more powerful. But yeah, to your point, there are a number of companies who use both some sort of big box powerful static analysis tool, as well as Semgrep in sort of pre-commit IDE PR comments, or like, hey, there's something custom to our code base that we want to flag, and we can knock that out in Semgrep in like 15 minutes.
Did you say that you also have for the IDE? You mentioned something about the VS?
Yes, so we have a VS Code extension, and I think a JetBrains extension, and I think a Vim plugin, and I think maybe, I don't think Emacs yet, but yeah.
No.
Yeah.
So yeah, there's actually, if you do,
I think that's great because actually, I mean, so you had JetBrains, which is probably IntelliJ is the most used for Java, and then Visual Studio for the .NET, which means that it covers a large portion of the landscape out there. So yeah, that's great because it actually helps to shifting even more left actually when you write the code.
Yeah, that's something a lot of companies ask us about, because like, hey, we want to give developers feedback as soon as possible, and IDE can be an effective way to do that.
Excellent, thanks.
So, cool. Yeah, thank you.
Is there do you mind me asking? Is there a command line version of this?
Yes, totally. Yeah, if you want to do like just like pip install or homebrew or Docker or whatever, yeah, it is sort of by default a CLI tool. It's just sort of I'm trying to show you like a nice, easy UI, but like very easy to run via CLI.
Okay, so you could, in theory, embed it in a shell script and run it multiple times across multiple files.
Mm-hmm. I like your thinking. Yeah, we've prototypes and stuff like that actually, where the results from one query get fed into the next one, and you just sort of like chain them together with Bash or like a quick Python script.
Right.
Yeah, we are going to build that as like first-class functionality into Semgrep. To be honest, we just haven't yet figured out like what exactly that should look like. But yeah, I'm sure that'll come at some point.
All right. Okay. And in the window that you posted the code, is there a limit on the number of lines of code that you could put in to be parsed?
I don't think so. Yeah, I mean, if you wanted to, I guess you could try to like put in like a million lines of code there, which might make it run more slowly. But yeah, no, I think I've included like hundreds of lines of code there, and but yeah, if you like want to scan a whole repo, okay, yeah. So for example, if I have like some example repo, I just forked one of Netflix's repos. If like you wanted to, you can just run something like semgrep -- config, and then you can pass it in like, let's see. You could pass it in like one of these, or one workflow that I kind of like is you're like iterating on a pattern here. And if you click share, it like gives you a URL, and you can just like sort of run that directly. But yeah, it's I would say it's like a first-class CLI tool, and it just so happens to have like a web playground.
Right. Okay. So any size, you can pass it any size file in theory, and it should be able to parse it, and then it will just dump out the selected lines that have the pattern that you're looking for, type thing.
Yeah. And if you want, you can also get JSON output. So say, for example, you're like, well, I want to put this in a pipeline and connect to other things. So yeah, you could like output the results as JSON. Then you could like pipe it to JQ and like, like pick something out of the match.
Nice.
Yeah, one thing pretty cool is that like these meta variables you have here, that gets passed through in the JSON output. So if you want to extract a couple of different pieces of code, like using meta variables, you can like, yeah, I can show you a quick example of that if you're curious, but yeah, CLI tool. Yeah, I guess, let's see. Sorry, Katie, how much more time do we have? I want to be respectful of people's time.
I think another hour or.
Okay, cool. So,
I mean,
yeah, how about
up to 8, so it's up to you how we do this time share or time. How we use the time. Let me put it this way.
Well, yeah, so I personally really like the CLI workflow, so I can show you a little bit of that in a second. Yeah, I guess, how about this? Let me show you like a couple more simple examples to show you how sort of the Semgrep rule writing primitives, and then we can look a little bit at like sort of the CLI workflow, where if you're like auditing a code base and you're like, oh, I want to like iteratively explore it and like extract things out of it, we can do that. Yeah, does that sound good? Cool. But yeah, thank you very much for the questions. Feel free to stop me at any time.
Yeah.
Okay, so far we've looked at like what can one pattern express, but sometimes you want to be a little bit more complex. You want to like compose patterns. So say, for example, you have, like I want to match this or this, or like I want to match this and this, or this but not that, or something like that. So Semgrep allows basically composing patterns using sort of Boolean like operations. So let me show you an example. So let's say we wanted to find potentially dangerous calls to exec. So in my opinion, that would be exec such that the first argument is not a string literal, because if it is just a string, then the user couldn't control it, so they can't sort of influence what command is run. So to do that, we could do something like this. We could say, let's find all calls to exec, but let's filter out. So and is not calls where, so there's a special syntax where it's like quotes and then the ellipsis operator inside. So what this says is find every call to exec and filter out the cases where the first argument is just a string. And the ellipsis operator here means there can be 0 or more extra arguments. So if we run this, notice that we're not flagging this case anymore, because this case is matched by here, and this and is not clause is filtering it out. But we actually are still matching this case, and this is not actually unsafe, right? Because there's no arguments. So really what we probably want this to be is like, there's at least one argument, and there can be more, that's fine. But filter out the cases where there's the first argument is just a string. Yeah, so this is an example of composing clauses. So there's a number of them exposed through the simple editor here. So this is like multiple things can match. And is inside is like your reasoning about the context. So there's a couple here, but if you go to the docs, there's actually like 15 other things you can do, but here's just like a few examples. So if you look at the YAML that is like the actual definition of this pattern, we can see that there's like this patterns clause and a pattern either that says like any of these things can match. And that's sort of the first thing that we wrote. And then filtering out basically this. Yeah, so we'll look at a couple of examples of like also combining pattern clauses, but this is just sort of introducing you to the idea. Yeah, any questions about this before we go to the next example?
So do we have any options for going through the whole list of projects, or it is only by file? Say you want to mainly search for a pattern, a vulnerable pattern on the whole project, the whole list of files.
Mm-hmm. Yeah, totally. So this is like when you run Semgrep like this on the command line. So like in the web editor, you're just like running it on one file. But generally in the real world, what you actually do is you run Semgrep and you say run this pattern, and then it's going to run recursively on an entire directory of files.
Right. So it's going to be based on I run on the top level directory. It notes all the files recursive to that directory. It will go ahead and search and run.
Yes. Yeah. So it, I think by default respects your getignore file. So if you have like files ignored by getignore, it won't run those, but otherwise it'll run everything in your directory. I think we don't see it here because it's implicit, but basically there's also like a languages key, which the editor is sort of hiding from you. But basically, like you specify, hey, this is my pattern. I want it to run on this language. And then Semgrep knows for a language what file extensions correspond to that language. So you can write like a Python rule, and you can run it on a repo that has Python, Java, Golang, Ruby, whatever. And it's only going to run a Python rule on Python source code. So like you don't need to worry about that. Yeah, does that answer your question?
Yep, perfect.
Cool. Yeah, thanks for the question.
And that file, you can create a set of rules in a particular file and use that to validate a file as it becomes available. Is that right?
Yeah, so there's a couple of ways you can write rules. So one is you can have one YAML file with just a huge list of Semgrep rules and like patterns inside, or you can actually have basically one rule per file. And there are actually some benefits of doing it that way. And oh yeah, and when you are running Semgrep here, so I started creating a couple of rules that I can show you in a second in this repo. So I've got like this HTTP string literals rule and this route detection rule. So if I were to do semgrep config and then pass in this directory of rules, then it's going to run all of the rules in this directory on, say, all of this repo. So yeah, you can run like one rule at a time. You can run like a whole group of them at a time. The reason I said that it can be nice to write one rule per file is because we actually sort of like, best software engineering practices dictate that you have unit tests, right? Like when you write something, you want to make sure that it works how you expect. So yeah. So here's, so again, this is the public, so these Semgrep rules are automatically pulled into our registry. So I showed you like the nice like web front end before, but the sort of implementation of those, like those YAML files and test code is in this repo, as well as some community contributed ones. But so if we look, let's say here, notice that there's a series of files that are, something .java, and then whatever that same thing is .yaml. So these are basically unit test files. So here we are saying this is the pattern to look for. So we're saying, see if the file imports this thing, and then look for some code that looks like this. And what's also nice is we have this like metadata field, which you can put arbitrary things in. So if there's something specific to your company that you want to annotate, you can do that. But basically, so this rule is then ran on this test code. So similar to ESLint, Bandit, and other security tools, there's a way to basically annotate, I expect this line of code to match. So basically, if you do a comment and then rule ID, colon, and then whatever the rule name is. And then I think, let's see, there's also a way to say like, I expect this line of code not to match, where instead of rule ID, you just say like, okay. But basically what you can do is like, as you're writing these test code plus semgrep rule YAML files, you can run semgrep --test. And then it'll basically take every rule, run it against its corresponding unit test file, and make sure that it matches the code you expect it to. So I found this really useful because when I'm writing patterns, sometimes I'm like subtly wrong, or I intend to catch a case that I don't. So I'll like write an initial version of a rule, I'll run it on a repo and be like, oh, did I find the things I expected to? Oh, I actually flagged this other thing that I didn't intend to. This is kind of some noise. I want to filter this case out. And so I'll update my unit test file to add a case of like, okay, make sure you don't match this because it's a false positive. And you can sort of iterate and document what you expect to match by having like one file for the pattern and one file for the code that you expect that pattern to match. And that's basically what we do for our rules to make sure that they're working as expected and that we don't introduce regressions accidentally. So yeah, it's a good question. Does that answer your question?
It does, yes. Thank you.
Cool. Yeah. Thank you. All right. So let's see.
Clint, I have a couple of more questions.
Yeah, please.
There's the question that I have. An example that you showed with the exec and ls strings. You assume that it's a string, but what about the case? Because obviously there will be no command injection if it's just a string. But can you show us an example where there is a concatenation? So if someone is doing an exec and then they do a string, for example, I don't know, cmd.exe or ls, and then they concatenate something with it, because that's actually how command injection can happen. What would the rule look like in this case?
Yeah. So just to make sure I'm understanding you properly, is this sort of what you're talking about? Something that looks like that, maybe, where it's like some user-controlled thing plus, or I guess it could be the other way, right? So it could be like maybe. Like you're thinking about like these two, maybe?
Yeah, exactly. So that's for your typical command injection example.
Cool. Yeah. That's a good question. Okay, so let's just check it out. Cool. Yeah. What we wrote already works. So again, this thing can be like a complex expression. It doesn't have to be just a single thing. And this is filtering out all the cases where it's we can prove that it's just a string. Yeah, actually, let's try another example. So let's say I forget exactly the current state of this, but let's see how this works. Cool. So even though this is a variable and this is like a constant, but again, not like directly a string. So Semgrep has been adding recently some constant propagation, which basically looks at a variable and reasons about what possible values it can have. So in this case, Semgrep is able to say like, okay, so I see you're calling exec with x. What is x? Well, I see that we gave x like a string literal value, and I can see that x is not redefined between that definition and when it's used. So I know that this, even though this right here is not directly a string, I can prove it's a string, so I'm not going to match this. And then here we know that y is a constant, and similarly, it's not like modified before use here. Yeah, so basically the rule we already wrote will handle, I think, the cases that you described, as well as actually automatically handle a couple of other cases we haven't discussed yet. Yeah, does that answer your question, or am I interpreting you correctly?
Thanks. Yeah, it just basically wasn't that obvious that the concatenation would be covered. And that's basically the thing. Do not match only little string, and match when there is basically an input into the method. And I think the second question, I just tried to do the pip install of Semgrep on Ubuntu, and that didn't seem to work. Is there is there something which needs to be done for the pip for the ease? Or was it just the apt update missing? Is there like when was the latest Python package released for it?
I think we should, like, every time we release a new version of Semgrep, which is like weekly, we should also push a new version to
might be
MyPy.
Yeah, don't worry. Yeah.
Yeah.
Sam,
are you using?
I think issues. Sorry, I think some is issue on your side, because the second ago I managed to install Semgrep on my Windows.
Yeah, and it worked on my Mac for some reason. Didn't work on my Ubuntu VM. Must have been the.
Yeah, so I will say one thing. We have tested Semgrep probably the most on Mac and somewhat on Linux, and I would say probably the least on Windows. Yeah, if you come across any errors, there's also, I think, currently sometimes an issue with the new M1 Macs. But yeah, if you have any trouble setting things up, like, please let us know. We'd love to iron that out for you as soon as possible, because that's like super annoying.
Yes, if I have any problems, I'll be screaming and you can hear it wherever you are.
Yeah, please do. So actually, the best, easiest way to give us feedback is to just go to the Semgrep GitHub repo and just I would maybe like do like a quick search for, I don't know, like pip or something like that, just to like make sure it's like a new thing. But yeah, if you come across anything that's not working, like yeah, we're pretty responsive to things like those. And if you have so this is more for like, hey, I encountered a bug or something's not working. If you are trying to write a rule, for example, for code you're auditing or something you're looking for internally, feel free to also say hi on our community Slack. So r2c.dev/Slack, which is basically like there's a general and rules channel, which is like just people like, oh, hey, I'm trying to do this. How do I do that? And then we have people who are like, both people from the community as well as us, like constantly answering questions. So usually we get back to people same day or even in a few hours.
Awesome.
So,
Are you also on the Stack Exchange?
a little bit. I think not too much, but we should be. I feel like we answered a few questions there, but mostly people seem to ask questions in Slack. But I think that that would be good.
Okay.
Yeah, we should have a bigger presence there. I would say, like, feel free to ask there, but then like make sure you send us a link so we make sure to see it.
No problem. I have a quick question because I'm looking at a couple YAML rules, and do you have one YAML per file, or can you combine all the rules within a single YAML file?
Yeah, so I would say if you're writing rules, I would encourage you as sort of a best practice to have one rule per YAML file, but you can have all of them in one if you want to. So if you look here, so notice how the rules key, like this this ID is a list. So so yeah, we could like put like a bunch of these here, and then like obviously these have the same ID, which needs to be unique, blah blah blah. But like yeah, you could have like 50 rules here if you wanted to.
Okay, awesome. The reason why I'm asking is because I'm looking at a plugin for IntelliJ, and it requires me to add location for the rule and ask for a specific file rather than directory. Hence the question.
Yeah.
Okay, I'll be experimenting.
Yeah, CF. Yeah, so the way Semgrep works is like, I think the way you call it is you just pass a like a path to like whatever rules to run, and that path can either be one specific YAML file or like a directory. So I would say maybe try pointing it at a directory and see if it just works. But if it doesn't just work, I think John Melton built that, and you should just raise an issue on his repo and be like, hey, please make this work for me. Yeah, I forget exactly where that is. But yeah.
Meanwhile, you're searching, I have one more question. So what about the frameworks? Say, for example, if I have a configuration of a framework, say like Django or any particular framework was wrongly configured or missed a configuration, so that also lead to the vulnerability. It is not part of the just language. So do you have the default rule set for me to just go and check the configuration of the frameworks, mainly the Ruby kind of code, which has a hugely compressed code, and only the configuration expands the code a lot. So when the configuration is done in a wrong way, it leads to a huge amount of vulnerable code. So can we use Semgrep, and do you have any default rules to go and check the frameworks as well?
Yeah. So I would say we do have some rules for those sorts of things already. I'm sure there's some things that probably exist that we don't have already, that if you know of and we don't have, like, I'd be happy to do that like immediately for you. But I do know we have some checks for that sort of stuff already. One thing that's kind of neat that I think gets at what you're saying that we haven't talked about so far yet is, so we have, so basically how static analysis tools work in general is, for each language you support, you need to have a parser that can take that language, parse all the coding constructs, and move it into a abstract syntax tree, which then generally gets converted to like a generic syntax tree, which is then mostly similar across languages. So your pattern matching logic is actually the same because it's implemented in the core. So you have like you have a different front end for every language. So when a static analysis tool says, oh, we support Go, we support Java, what that means is they have like a front end that can take source code and turn it into a intermediate representation. But we have kind of a cool hack that we built that Martin built called generic pattern matching mode. So what this does is it's you can actually run it on any type of file, like XML, Terraform, or just really anything. So it basically looks at arbitrary text and then tries to use things like quotes, braces, and indentation to infer meaning. So technically, Semgrep supports infinite file formats. It's just whether or not it's like really good at it. And yeah, let me show you some quick examples of that. I was going to save it for the end, but it's contextually relevant now. Yeah, so here's an example. Let's just go here. Yeah, so this is using generic pattern matching mode, and this is HTML. So Semgrep doesn't support HTML. We do not have a parser for HTML. But if I were to do something, think like this. Yeah, so again, Semgrep will eventually, but currently doesn't actually understand HTML, but it does understand things that are source code E using generic mode. So what we're saying is like, there's like a less than sign, a script, some other stuff, and then other stuff inside, and then eventually some closing brackets. So actually we have just released, as of like last week or something, this new clause called metavariable pattern, where you can basically, you can't do this yet, but soon you're going to be able to do something that looks like this, and then you'll be able to run JavaScript Semgrep patterns on the JavaScript you've extracted from HTML. So you can imagine like templating libraries, like React or Vue.js, or like Docker files or places where you run bash in a config format. Like soon you're going to be able to like basically surgically extract pieces of other types of files and then run Semgrep on them, even if they're like another programming language. So you can't do that today, but probably in the next few months, you'll be able to do that. But yeah, but for now though, you can say something like, it's not, yeah, I think something like, this. I forget this part actually. Yeah, let's cheat. Good job, Castany. Oh yeah, I needed something after. Yeah, so here, again, we don't have like an HTML parser, but using generic mode, we can like reason about arbitrary file formats. So I've also written like XML patterns and things like that, even though we do have first class support for JSON and YAML. So you can use like fancier Semgrep features for those, but HTML and XML not yet. But using generic mode, you can sort of slice and dice. Like I've also used generic mode to write patterns for like requirements.txt files, or that's what Docker files and Kubernetes configs and Terraform use. Actually, like this past week, the one of the founders of HashiCorp, the guy who created Terraform, actually was working on a Terraform tree sitter grammar, and tree sitter is what we use to parse basically all the different languages. So probably we're going to get first class Terraform support in the next couple of quarters. But yeah, so basically, sorry, this was a long way to answer your question, which is yes, any sort of file, like if it's a programming language, you can use all of Semgrep's features, but if it's any text file, you can use some things. And there's a bunch of limitations for generic mode because it doesn't actually understand the source code. Like I think patterns can only span, I don't know, 15 or 20 lines, and meta variables and stuff like that only kind of work sometimes. Like sometimes there's edge cases that don't work like you would hope they do. But we're making that better. But you can use some things out of the box.
This should be sufficient for framework-based vulnerability, right? So it's hardly going to be much more simpler than what you've shown now. So if we can write those syntax, then wherever the configuration, or when there is a less compressed code, the configuration which expands the code, when it goes wrong, we'll be able to easily detect those vulnerability. Yep. Impressive.
Yeah. And yeah, if you use a generic mode for some cool stuff, like please let us know, because yeah, I'd love to hear about it. That'd be fun. Yeah. Any other questions? Thanks for all these great questions. Makes it much more fun.
One other command line question, please. Can you understand whether the match was successful or not on the command line by some sort of test? Does it return a particular value, like a Boolean value, or 0 for success, or whatever, or 1 for success? So you can.
Yeah. Sorry, keep going.
Yeah, I was going to say, so you know whether you found the pattern you are looking for in that file, and therefore you can stick it in a script and have it run overnight, come back in the morning, and you can see whether things have changed and so on.
Yeah, so I forget what the default behavior is, but yes, there's definitely ways for it to either return like 0 or 1 if it finds something, or like -1. I think, yeah, I'm trying to remember. I think we changed like what some of these mean recently, but I think, yeah, so there we go. So I think --error exit 1 if there are findings. And I think there's like a couple of others, but yeah, it is easy to do stuff like that. But yeah, if you have a use case that is not already supported, yeah, please let us know.
Right. Okay. So it leads nicely onto CI and say running overnight. So
yeah, although mostly like, so in our experience running on well, it depends how many rules you're running. Like if you're running like hundreds of rules on like millions of lines of code, it might take a little while. But I would say in my experience, and we can look in a second, but I would say running like a medium set of rules on like hundreds of thousands of lines or even a million lines, I think should take under an hour, maybe like tens of minutes. Wow. Yeah. Yeah, actually, okay. So I don't know. Let's see. Let's just try. So I'm in, just because I have this repo open, I was planning to show something else with this, but let's try this because this is a good question. So Toke is a tool to just say like how many lines of code is in stuff. Let's see. So let's say lines of code. So this is not super big. This is like maybe 130,000 lines of code. Let's find like some random rule pack. Let's say like security audit. This is like maybe some more rules than R2CCI. We can just copy this. Let's just run this here. So this is running like 245 rules on like 130,000 lines of code. So one thing to bear in mind is that different rules take different amounts of time. So for example, like if you are writing a rule with like tons of the ellipsis operator and you have like 5 of them everywhere, like Semgrep will try to sort of both like greedily and like there's basically like, is it like, okay, does it match just this expression? What about this line of code? What about like these 5 lines? Sort of how regex is, you know, you can have like regex DOS where depending on the regular expression, it can be slower or faster. If you are sort of like, so to give you an idea of a pattern that is sort of like subtly very slow, is if you had a pattern that was like just this, for example, so just $X is going to match every function call, every class name, every expression. So it's like going to match a bajillion things. So because it's matching so many things, it's going to be slow. Right. And we do have some Semgrep rules for Semgrep rules. So we have linters for rules to like help tell you if they're going to be slow. But anyway, so I just like with any static analysis tool, like there's sort of different speeds of various things. And the reason I say that is not to be like, oh, like this, you know, is the author's fault or whatever, but just like it depends on the repo, it depends on the rules. And this is true with any tool. So at least in this isolated circumstance, about 245 rules ran on about 130,000 lines of code in about under 2 minutes. So here, and this is what the output looks like. So these are probably going to be miserable to read because these are, like just resource JavaScript files that are minified. But here we can see it's flagging some like new functions. Here we can see has like a permissive CORS policy. Oh yeah, and this, so if you look at the YAML here, this like severity, like currently it's like warning, info, or error. We're probably gonna move to like low, medium, high, like and stuff like that soon. But so we can see that displayed here. We can see sort of the rule ID found, link to more info, and then the message that you put in here is then displayed here. And it gives you like a little code snippet of what was matched. And yeah, all of this, if you do like --JSON, all of this will be like in JSON output. But
right, so you can actually put in a flag if you like, some text to indicate that you found something or you haven't. Right.
Yeah.
Okay.
In the front of CA integration, so this whole tool is going to run in the build agent, am I right? So
yeah.
So do we have some kind of so when I need to prepare the build agent to run this particular steps in the CI, so do you have some kind of an extension for Jenkins and for ADO, or do we need to prepare that mission for it?
Yeah, let me like quickly jump to that. Yeah, so basically, because Semgrep builds to like a nice CLI binary with JSON output, basically any build system that you can put either a Docker image or a CLI tool in, you can integrate Semgrep pretty easily, usually in like 3 or 5 lines of config code. And I can show you some examples of like what that looks like. But basically, any CI system you can put a new tool in, you can put Semgrep in. One thing I wanted to mention that's pretty exciting is as of like 2 days ago, GitLab 14.0, the new long-term release for this year, their SAST product, which wraps a bunch of open source tools, they've actually started ripping out other tools in this release, Bandit and ESLint, and they're replacing it with Semgrep actually. So we had already written a bunch of Bandit and ESLint rules, and they sort of wrote a few more. And so basically over time, their plan is to replace all of the tools they use with just Semgrep. And so if you're using GitLab SAST, you're actually using Semgrep under the hood. And which is pretty cool because I believe GitLab has about 30% of the code hosting market share, supposedly. I think I saw some stats. So basically, yeah, for 30% of code hosting projects, if they are using GitLab SAST, they are already using, or they are now using Semgrep. So that's pretty cool. But to answer your question, so basically we've been talking about Semgrep CLI. We also have something we call Semgrep Agent, which probably we need a better name, but basically it's just like it's basically Semgrep in a Docker with extra CI goodness on top. So it makes it easy to be diff aware. So if someone does a new pull request, you don't want to find everything. You want to find just new findings in the code that's been changed. It makes it easy to integrate into, like there's some like intricacies for like GitHub versus GitLab versus Travis versus Jenkins, whatever. Like there's some like just annoying things that we try to like bundle all that complexity into this Docker image so like you don't have to worry about it. And we also try to make it easy to write like PR or MR comments because that's something that like basically everyone wants.
So all your agents are Docker based?
Yes.
So I need to just have the Docker engine running on the build machine. That's it.
Yes. Yeah, and I think you said Jenkins specifically. Let's. Yeah, I know we have like an example of Jenkins config. Jenkins. Yeah, I think we have an example thing that hopefully you can just copy and paste in.
Yeah, it is.
Yeah, just uses the Semgrep agent
same
Docker.
Yeah, that's right.
But yeah, if this doesn't quite work how you intend, let us know. We'll update those docs.
That's absolutely fine. So just I thought if we need to pre-prepare the build mission with the dependencies of Semgrep, then do we need to think in that way? Or if you have just a Docker image ready, then we need to have the only Docker engine running on that particular mission, and the build step will automatically pull the Docker image and start running and doing the testing. So yeah, this is pretty easy.
Yeah. We were like, okay, initially we focused very much on like the CLI tool and making all that stuff good. But then as more and more companies were trying to integrate Semgrep into CI, and they were like, hey, I'm trying to use it in GitHub, but it's annoying. I'm trying to use it in Jenkins and it's annoying. So we just tried to basically like figure out how everyone was trying to use it and then just build that into something you can just use in ideally like 5 minutes. So yeah, if it takes you more than like 30 minutes, like raise an issue and like complain, because we should make that easier for you.
So is there anywhere I can say, hey, yes, I know this, you're throwing an error, but I would like to mark it as a false positive. So the subsequent scans, I don't want to show. So if at all I need to create some persistence on the scan to scan, how do I do that? So is there any possibility or?
Yeah, there's a couple of ways you can do it. Yeah, so basically, similar to ESLint and Bandit and other tools, you can basically write a comment either on that line or above that line, like sort of as an annotation right above the line that says, hey, no Semgrep, and then whatever rule you're like, this isn't actually a thing. If you want to, say, ignore an entire file path rather than one specific finding on one specific line, you can have sort of like a git ignore, but a .semgrep ignore, which will basically say like, hey, so I think Semgrep agent already tries to be smart about like inferring some files that should just be ignored by default. But if you're like, hey, this is like vendor code, or this is like our test repo, you can just add a Semgrep ignore file. Yeah, one subtlety that sort of bit me recently, so I just want to mention, is like, so if you're using Semgrep agent, you can use the Semgrep ignore file. But if you're just like iterating on the CLI, you have to use this exclude flag. For some reason, the CLI doesn't currently use the Semgrep ignore, which annoys me, but we will fix soon, hopefully. Yeah, and you can also, so if you are writing, so rather than ignoring a path for every rule, if you're like, this specific rule, I want to ignore paths, you can also do that. So yeah, exclude. Sorry. And you can say, like, in this rule, exclude these specific paths. So like, these are my test files or whatever. So you have a couple of layers of granularity. You can say like, for this repo, ignore all of these files. For this specific finding in this file, ignore this line of code. Or like, for this rule, ignore these paths. So if you want something that's different than that, yeah, we can add that too. But that's sort of the granularity we have now.
Got it, yeah.
Yeah, so one thing that we haven't mentioned yet that I think is pretty cool is, this is still like early stages, to be honest, but we're working on auto fixes. So we don't want to be a tool that just finds problems. We want to make it easy for developers to fix. So let's see, we can actually just like go to this and see what it looks like. So let's just peek at the solution. Yeah, so basically, this is an example I gave in a workshop once, but basically there was, I think the We45 people made this cool vulnerable Flask app. And what it does is it's always like doing a JWT auth token check at the beginning of every route. But we might want to say for every new route that a developer creates, you should do this JWT check, or this could be an annotation, or like it could be whatever. But so basically we were like, okay, find every route and then filter out the routes that do a a JWT header check. So find all the unauthenticated routes when you combine those two together. And then this is sort of a hack, but so using GitHub's API, when you write a comment, you can do backtick suggestion, and then like input arbitrary like code there. And then when it shows up in the PR comment, it looks like a suggested change that you can just click a button and it'll apply. But what's neat here about, you know how we said how meta variables you can interpolate in your message? Like, so we can do that same thing here. So like we matched the path and the HTTP methods and the function name and stuff like that. So we can actually use those meta variables in this Autofix suggestion. So that ideally we can just be like, hey, developer, like, I'm not going to just tell you like, hey, don't do this thing. Here's like, just click this button and it's fixed. So I think Autofix is very promising. It's still early stages. If it's like a multi-line complex fix, it might be hard to do. But if it's like a one-line semi-simple fix, I would say it probably works. So yeah, if you look at the docs, yeah, so if you look at the docs, search for Autofix, you can read a little about it there. And so basically the cool part is like you can reuse the same Semgrep pattern syntax you're learning for specifying the fix for something. But yeah, that's something that's still early stages, but I'm quite excited about personally. Yeah, so one thing I wanted to mention is, so we built Semgrep to be like a super useful CLI tool, and like all the rules are open source and all this stuff. But one thing we found a number of companies were having problems with is basically like, how do I manage Semgrep at scale across 50 or 100 or like 1,000 repos? Because you might want to set scanning policy. You might want to do stuff like that. So one thing that we've been working on is basically like a SaaS dashboard to basically say like, for these repo, run these rules, collect the results, and stuff like that. Just like a quick comparison, everything I've shown you so far is open source. The SaaS app is not open source. It is free to use, and you don't need to talk to anyone to use it. You can just start using it today and run it on as many repos as you want. But it is not open source because hopefully, that's like how we're trying to not go out of business, so we can keep building a cool open source tool. But let's see. Yeah, basically, like what happened was we were watching a lot of companies build their own thing. So, there's like 5 to 10 companies who are like, okay, well, we like Semgrep, we want to roll it out in CI, but these things are very painful. So one example is, let's say you write a custom rule and you want to run it across, say, 50 repos. Well, you could put it into every repo in Git, but then you're going to have to like, every time you update that rule, you're going to have to do a PR to 50 repos. Or maybe you put that rule in a centralized repo, but then that has to get cloned somewhere. And then it's sort of like distribution is a problem. You might also want to say, like, if this rule fires, block the build. But if this other rule fires, like, this is okay, I just want to be alerted as the security team. So say, for example, a developer is starting to use crypto in a file that's never had crypto before, like that might be something you want to know about, but it's not something you want to block the build over. So we wanted to make it easy to basically send yourself like an email or a webhook notification or a Slack comment or just like whatever to say, hey, this was found on this repo in this PR. And also like, metrics, trends, what's getting fixed, whatever. And so just like some key things, we try to take as little information as possible because we're very like, least privileged security conscious. So we never see your code. Your code stays in Jenkins or GitHub Actions or GitLab runners or whatever. Again, just the Docker image is running in the environment you're already using. And there's no separate infrastructure for you to run. But yeah, so like if you're like, hey, like I just want to roll my own, like feel free. A lot of companies do, but one thing we've seen from a couple of people is like, yeah, getting diff-aware scanning is kind of annoying, and PR comments and integrations and stuff like that. It's like, you can build it, but it is kind of logistically annoying. But yeah, we have like a very extensive, like, use as much as you want free tier. You don't have to talk to anyone to get set up and get started. So yeah, just wanted to mention that, because it's sort of, if you're thinking about CI, I would say set up like whatever you want and just sort of like see how it goes. And if you're at some point getting to the point where you're running it at scale and you're like, this is kind of more overhead than I want, then you can check out a dashboard we've been building, but you never have to. So yeah, let's see. And then, yeah, we already talked about the VS Code extension. So yeah, any more questions? Happy to get into some, I don't know, more examples, or just whatever.
Slightly bit not related. What was the page I can report the issues?
Oh, great. Perfect. Yeah, I would say if you're having issues with Semgrep itself, I would go here. If you have like a false positive or something like that, feel free to create that on the Semgrep rules repo.
Okay.
Yeah.
I have a problem with running it. As I said earlier, I'm running this on Windows, so it might be related to that.
Yeah. Let's see.
Okay. I'll raise the issue.
Yeah, Windows support is mixed. I think it should work with Docker, but I don't know if it's like native support yet.
Unfortunately, I'm not able to install Docker on my company machine.
I've just got it running on Windows. It's fine.
Oh,
Windows
wow.
10. Yeah.
All right. I just got the error when I tried to run it. It was #1 is not a valid Windows 32 application.
I don't know if it makes any difference. I was using Poetry as my install manager rather than pip, and it just went blip, straight on. It's fine.
Okay. No, I installed without any problems with pip, but okay.
Yeah, actually, yeah, if you don't mind sharing maybe on this thread like what worked for you, Adam, that would be super great. And yeah, if you want to provide more information about your Windows environment and the error you're getting, yeah, it's always useful for help us pushing this forward.
Okay.
But yeah,
thanks
for providing feedback.
No problem. Okay.
Yeah, so I think we have about 10 minutes left or so. So I have, I guess, another couple of sort of advanced examples. I've got some sort of like CLI workflow stuff. Yeah, what would you all like to see?
A more advanced example from my side, unless somebody else wants something else.
Yeah. Okay. Feel free to interrupt me at any time. Yeah. So I'm just going to do like a whirlwind tour of a couple of things. So far we've seen like sort of pattern either or pattern not, but there's like a bunch of other tools in your tool belt. So I'm just going to like touch quickly on a couple of them. So one is, even though we're a source code aware tool, regex is still super useful in practice. So you can combine Semgrep patterns with regex. So here we can say like find all calls to the Boto3 client where the host is like an IP address. Here, sometimes you want to be like class aware. So here you could say, I think this currently works in Java and Golang. You can say like, I want to find all calls to exec, but only when that class is a runtime object. So you can say like, this function or this class is of this type. If you want to analyze, say, JSON or YAML, you can do that. So this is like, for example, if you're looking at like IAM stuff, you can do that. See, we already looked at the generic mode. So looking at like HTML and things like that. Similar generic mode can be used for like Terraform or other like Docker files, Nginx configs, Kubernetes configs. No, I think that's YAML, but yeah. So basically, any text you can take a look at. If you really want like peak customizability, we have a pattern-where Python clause where you can basically put arbitrary Python in there. So most of our rules don't use that because obviously arbitrary Python is potentially dangerous. And in fact, to use that, you need to pass Semgrep a flag, dangerously allow arbitrary code execution from rules, which is of course disabled by default. So if you're like, hey, I want to match some things with meta variables and then do like entropy checks or like super complex, whatever you want in Python, you can do that. Let's see. So, okay, this is going to be a whirlwind tour, but let's just see if we can do it in like 2 or 3 minutes. Or maybe I can just cheat because I think maybe. Okay, cool. So again, this is a open source repo from Netflix. I've added in some authorization related annotations just for demo purposes because it's interesting. Let's say we had never seen this repo before and we wanted to extract all of the routes as a security auditor. This is useful. So let's say we searched for, say, some HTTP verb like post. We look through it a bit and eventually we're like, let's see, like, oh, okay, this like at post annotation looks promising. So we click on it and we look at this file and we're like, okay, so yeah, we're using JavaX. We can see that we're like, this resource is some sort of controller. Yeah, I'll make this a little bit bigger. And we can see like these are routes. So we can see this is like a GET request, another GET request. We can see the path and so forth. So let's say as a security auditor, like I want to find all of the routes in this application because routes are attack surface. This is where people can send data in and functionality they can start in an app. So let's see, I will take away my cheating. Let's say we want to find all the routes. Let's see how we can do that in about like 2 minutes. So let's take the source code that we want to match and just copy it into our rule. So need to get the indentation right because YAML is a harsh mistress. So let's look at this and think like, what makes this a route? Let's say, well, like at path, probably all routes have an at path annotation, but we don't care what the value is. That's going to be different on every route. So again, we can abstract that away. Just make that ... There could be a get or a post or a put or whatever. So we're going to delete that. Let's say we don't care about the description for now or these other 2 annotations. We don't necessarily know what the return type is going to be. So let's just say type, whatever. We don't know what the function name is going to be. So let's just replace that with a meta variable as well. Let's say function. And we don't know what the argument is going to be. So like there could be 0 arguments, there could be a lot. So let's just replace that with the ellipsis operator. And we don't necessarily know what's happening inside this function, right? So let's just say ellipsis operator, anything can happen. So if we think about like, what does this mean? This is any method that has an at path annotation, and we don't care what the return type is, we don't care what the function name is, and it can have anything inside, right? Okay, so cool. Let's see. Oh yeah, and then also we say this runs in Java. Okay, so let's see what this does. So we can say semgrep-config, pass it this YAML file that we've been working on, and if you don't specify path, it'll just run on your current directory. So in about 2 or 3 seconds, we looked at 536 files and found 62 routes. So let's look at these. Like, okay, this is like pretty interesting. So if you're wanting to like audit and, oh, by the way, if you wanted to like script this, you could then do something like, you know, JSON pipe to JQ and then like extract whatever you wanted to. And all the meta variables that we're matching, like this is sort of the raw JSON output. So you can see like, here's the lines of code that were matched. Here's your message. Here's the meta variables that were matched. So we can see this is like the name of the function, stuff like that. But okay, so let's say we realized that this @secured is interesting because probably authorization or authentication is happening. So let's find all of the routes that don't use that, because those are probably unauthenticated routes. So that's probably something interesting we might want to audit or even alert on in CI. So let's find unauthenticated routes, which, to use our trusty pattern not operator, we can basically just copy what we had before. One back. So we don't necessarily care what the permission level is. We just care that it doesn't have this annotation at all. And then this function, this is like sort of the same. This can be generic. So basically what we're saying here is find any method that has an @path annotation, because that means it's probably a route, and then filter out the cases that have this @secured annotation, right? So the output of this should be all routes that do not have this annotation. And if we run this, oh no, YAML. Oh yeah, sorry, we need this thing to show that it's on multiple lines. Yeah, we need to make like this less error prone. But yeah, so in basically like 5 minutes, we extracted all the routes. Then we found all the routes without an authn annotation. So here we can see that this, like something in QAdmin resource, like that sounds interesting. Anything in like an admin related file, I probably want to know. Probably should be doing some sort of auth. And then, yeah, so we went from like a bunch of code to audit to like 63 things to audit to 3 things to audit in like 5 or 6 minutes. And the prototyping rapid iteration speed. If we wanted to, we could write a rule that says, you know, every route that's defined in a class such that that class has admin in the name, and I would expect it to have an @secured admin, or like a, yeah, like specifically admin rather than anything. Like you can do that as well. So okay, so that is all. Yeah, I am happy to stick around for a few more minutes and answer questions. But yeah, thank you so much for your time and all your excellent feedback and questions so far.
Thank you. That was really useful.
Thank you.
Yeah, thank you.
So yeah, guys, if you have any more questions, yeah, please feel free to ask.
Yeah, I'll just slowly drink some water so you can think of them.
We kind of exhausted you.
Yeah, it's okay. It's always fun. Yeah, actually, the example about the string concatenation in exec is excellent. Well taken feedback. Yeah, I should add that to the example, and I probably will. So hats off to you. Well, cool.
Clint, one other one, since you mentioned this, in terms of finding, I know you said you have the OWASP rule set, right? So this is what's most interesting. People usually are interested in OWASP top 10 vulnerabilities. In terms of things like detecting patterns for SQL injection, how do they work? Can you sort of talk through them? Is it basically, are they actually looking for something which uses SQL with concatenation, without parameterized calls? Yeah, it would be good to have a look at the example of a SQL injection rule.
Yeah, thanks. Yeah, so I think we're sort of doing 2 types of things at the same time. So one is traditional vulnerability finding, where we are trying to model attacker input flowing into a dangerous location. And then we're also sort of simultaneously trying to find opting out of secure defaults, like any unparameterized SQL query. So let's, yeah, so I think this pack is, I think, looking for every call that's an unparameterized SQL query at all. Yeah, sorry, sometime. Let's maybe open this up in Playground to make it a little easier to see. Yeah, so I think this is looking for any concatenation and not necessarily proving that there is user input there. So trying to be like overly aggressive. But I think that we do have.
Go is probably a bad example. I think you picked the example Go.
Yeah.
Is there one in Java? I think that would be interesting to see.
Yeah,
one in Java or JavaScript.
Yeah, we can do maybe.
Yeah, but I can already see that there's like $X plus $Y, right? So basically trying to catch when there is a concatenation, but it's the concatenation inside the SQL query and what it's leading to.
Yeah, so I do know we have like a number of checks for Node.js in particular that are based on like route stuff. Yeah.
Yeah, there's execute query and there's just execute. Yeah, okay, it makes sense now.
Yeah, so for some cases we do have like this is clearly coming from the user, and other times I think it sort of depends on the focus of the rule. I think that is something we could probably make more clear. Yeah, I guess just to make sure I understand your question, it's like how often is it proving, or at least having strong guarantees or reasonable evidence that there are sort of user-controlled input versus sort of flagging dangerous coding behavior?
Exactly.
Yeah. Yeah, I think let's maybe, so some examples that I am more recently familiar with. Let's see, maybe this is easier to just do JavaScript, Express. Yeah, I know like a bunch of these things are yeah, looking for like, okay, you're in something that's clearly a route, and you're taking that sort of request response object and then directly like writing or sending. Yeah, so I would say in some cases, we're reasoning about control flow from the user, and sometimes we're more just trying to be overly cautious. We are adding so not just meta variables, sort of approximating control flow, or meta variables doing kind of what taint analysis is. We are adding sort of a full-fledged taint analysis mode that will still focus intra-file, but it will allow you to say like, here's all the ways user input comes in, and here's all the places that's bad if it gets to, and then the engine will just sort of map that for you. So that's currently like already in flight. It'll probably still be another few months maybe until it launches in sort of full support for all the languages, but it is currently in process. But we already have some rules like that today, but it'll be easier once they're sort of built in taint mode. So yeah, does that answer your question?
Yep, thanks.
Cool, yeah, thank you. Well, yeah, if you want to check out these slides, there's also like a bunch of links to different things. I think you can.
Is this set of slides available anywhere? Can we have it?
Yeah. Would you mind? Sorry, I'm not sure if I have like the. Yeah, I can probably paste this in.
You can put them in the GitHub for each chapter.
Yeah, feel free to share however you'd like.
Yeah, I'll do that one. And then you can look for the question that will be said.
And Adam, thanks for the feedback about poetry. That's good to know.
I didn't realize I was your guinea pig.
Yeah, well, there's always got to be the first.
Yeah, that's true.
Well, cool. Yeah, feel free to reach out with any questions on Slack or Twitter. And yeah, thank you all so much for your time, and thanks for having me. It's been a pleasure.
Thanks very much. So I'm going to end up this.
Yeah, I'll stop sharing so you can share if you want.